So question 15, again, we're going to try to factor this given polynomial. Notice again how it's a trinomial, but notice how it's not a special product because the 5 on the end there, you cannot square any number and get 5. So this becomes what we call a general trinomial. So in general trinomials, what makes this one unique though is there's a coefficient in front of the x squared. So now we're using this form ax squared plus bx plus c. So when there's a coefficient in front of the x squared, the strategy I suggest, since there's not a GCF or anything, we can't factor anything out of these, is we just go ahead and just use what's 4 squares. So what I'll do is I'll just draw a little, see if I can get this thing to draw a little rectangle. Give yourself some room above and to the side and make it big enough that you can actually put stuff inside of it. So we're going to create 4 spots. So using the 4 square strategy, what we learned is the quadratic term goes in the top left. So the degree 2 term, the 4x squared, goes in the top left. So the 4x squared is going to go here. The constant goes in the bottom right. So the constant is the number without the variable. So the 5 will go here. Now the catch is we got to create 2 linear terms. So we don't, the 12x has got to be broken apart and put into 2 spots. The way we do this is we multiply the quadratic term coefficient to the constant. In other words, a times c. So this a's got to multiply to the c. So 4 times 5 again is going to give us, wow, it's going to give us a 20 again. Interesting. Sorry about that. Thought we get a different example there, but we still get 20. Now the catch is we're going to use this number to create the coefficients of the linear term. So the factors of this number must add to equal the linear term coefficient. They must add up to equal the b. So the b in our question is the number in front of the x. That's the linear term coefficient, the 12. So I have to add up to get a 12. So in doing this, we know 1 times 20 is 20. 2 times 10 is 20. And I'm already seeing, wow, 2 plus 10 is 12. So there's my winner. I don't have to go any further. So 2 plus 10 is 12. So these become our linear term coefficients. And it doesn't matter what order you put them in. So I'm just going to go ahead and put the 2x up here, and then the 10x becomes here. So notice that the 2x and the 10x does give me the 12x. So the linear term gets broken into 2 linear terms. So this creates our box. Now, from here, I'm just going to model the rest of it. So from here, we want to identify the GCF of the top row. So what does a 4x squared and a 2x have in common? So it looks like the 2 goes into both of them, and they both have an x in common. So it looks like I can bring a 2 and an x out. Now, if we look at the bottom row, what do these 2 terms have in common? Looks like they both have a 5 in common. So I'll put a 5 out here. Now, what I do now is come up here to the top and finish out the problem. So here I have to ask myself, well, if I factor the 2x out, what times 2x gave me 4x squared? It looks like I still need a 2 and an x. 2x times 2x does give me 4x squared. So it does kind of work out there. And what times 2x gives me 2x? Looks like that's a 1. Now, if we go ahead and play this out along the bottom row, does 2x times 5 give me this 10x? Yeah. Does 1 times 5 give me 5? Yeah. So we've actually completed the factorization. So the outside edges become our 2 factors. So in parentheses, I put the first binomial, the 2x5 in it, and then multiply that to the other one because these are factors. And the other factor is the 2x plus 1. So again, if you use FOIL, it should check out and give you this. And notice how, since I've laid this out, remember, I can actually just check this way too. 2x times 2x is 4x squared. 2x times 1 is 2x. 5 times 2x is 10x. 5 times 1 is 5. And notice that do the 2 linear terms give me the linear term of 12x? Does 10x plus 2x give me 12x? It does. So notice how you actually can do the check right there in front of us using the box.